Hello guys, this is differential and integral calculus. Today we are going to focus on the limits. So, okay, I have these questions, actually the techniques on how to approach limits when you are given the limits, when they say find the limit of this. Alright, number one, we have let's take, maybe you are given the limit, which is this one. Then the first thing that you have to do is to do the direct substitute before you can attempt that question. Okay, for instance, let us take this one as our example. Is what? The limit as x approaches 1, we have the square root of x plus 3 and then plus 2 all over what? All over x plus 1. They say find the limit when x approaches 1 and then you are given your function. So we said number one, you have to do a direct substitute before you can attempt that question. Okay, we take our 1 and substitute it here. That means we are going to have the square root of 1 plus 3 and then plus what? Plus 2 all over what? 1 plus 1. And then this is equal to what? The square root of 1 plus 3, this is equals to 4. And then the square root is what? Is 2. Then plus what? Plus 2 all over 2. Then now you can see that your answer will be equal to what? Will be equal to 2. Then now after you have found you have the limit, then now you can use those properties. Remember, if you are approaching the limit, if you have the square root, this limit will come inside here and then also here, and then will also come down here. That means we are going to have, this will be equal to the limit when x approaches 1, and then we have x, plus the limit when x approaches 1, we have 3, and then we have the square root. Then plus the limit when x approaches 1, and then we have 2. Actually, it's a distributing part. And then all over, we also distribute down here. The limit when x approaches 1, we have x. And then plus the limit when x approaches 1, we have 1. Then now we substitute our what? Our 1. We have the square root 1 plus the limit when x approaches something, while we have a constant, it will be that constant. That means here we are going to have 3. And then plus, we can see this one is our constant. That means it's equal to what? 2 all over. And then here we substitute our 1. We have 1 plus this is our constant. It will be our constant. Then now we have the square root of 4 plus 2 all over 2. Then this is equal to what? 2 plus 2 all over 2. And then your result will be equal to what? Will be equal to 2. Then that is your answer. We call this one the direct substitute. So let us pick another example. The limit when x approaches 3, we have x squared minus what? Minus 9 all over x squared minus 4x plus 3. Remember, we said number one, you have to do a what? A direct substitute. Let us substitute our 3 here. We are going to have 3 all squared minus 9 all over 3 all squared minus 4, 3, and then plus 3. if you can check, 3 to the 2 is equal to 9, minus 9 is equal to 0. And then here we have what? We have our 9 is 9 minus 12 plus 3, which is equals to 0 as well. And then we have 0 over 0, and this is not allowed. That means if you have 0 over 0, then now that means this one is an indirect substitute. So on indirect substitute, we have two parts, which is a factorization method and the rationalization method. Okay, how can you see that this one is a factorization method? You can see it by x squared and then and so forth, x to the 3. So you can see that this one is factorizable. And then now we can see that this is our x squared minus 9. We can factorize this part. Then let us go on. This will be equal to the limit when x approaches 3. So we can open two brackets. We have x, and then we have 3 and 3. I believe that you can factorize. Then this is plus or minus all over. Then the factorization of this will be, we open two sets of bracket. We have x, and then we have x this side. Then we look for the factors of 3. That will give us what? 4. So since this one is positive, it tells us Kuri is what? Is the same. Is same. And the same means you add. So let us check the factors of 3. We have 3 multiplied by what? 1 is equal to what? Is equal to 3. Since this is positive and it tells us Kuri is the same, we have to add our factors so that we get our middle term. So let us add them. We get 4. So since we got our 4 and the middle term has the negative sign, that means here we must put negative and what? And the negative, because it's the same. Then we put 3 and 1, our factors. Then now you can see this one is the same as this one, so they divide each other. Then now this will be equal to the limit when x approaches 3, and then you have x plus 3 all over x minus 1. Then now from here you can distribute your what? Your limit. This is equals to the limit when x approaches 3, then you have x plus the limit when x approaches 3, you have 3. And then all over the limit when x approaches 3, you have x minus what? The limit when x approaches 3, you have 1. Then now you substitute your what? Your 3. 3 plus, since this one is a constant, it will be 3. And then now we substitute our 3 minus what? 1. This is equal to what? Is equal to 6 all over 2, which is equals to 3. Then this is your answer. I hope you understand. Alright, we call this one an indirect substitute by factorization. Then let me pick another example based on this. All right. Let me pick another example. All right. We have the limit when x approaches -2, and we have x to the 3 plus 8 all over x plus 2. So we can see if we can substitute our 2 here we are going to get 0. and also here we are going to get 0 by direct substitute. So meaning you have to do those method, which is factorization method or rationalization method. But here, since we have x to the cube, that means we have to do what? A factorization method. So if you have something like this and you want to factorize it, first of all, you are going to change your 8. So if we change our 8, this will be equal to x approaches negative 2. This is x to the 3, and then plus what? 2 to the 3. They must have the same what? Exponent. Then now all over what? X plus 2. Then from here, since they have the same exponent, then now we can factorize. This will be equal to the limit when x approaches negative 2. First of all, we are going to take our basis when we factorize such a problem. Is x plus 2 and then open bracket. Then now we are going to say x to the 3 divided by x is equals to what? Is equals to x to the cube. Then the other step, since this one is positive, here we are going to write what? Negative. But if here we had a negative, here we're going to write what? Positive. So the other step, we multiply x multiplied by 2, we are going to get what? 2x. Then here is always positive. Then you say 8 divided by 2 is equals to what? Is equals to 4. Then you close bracket. All over what? All over x plus 2. Then now you can see this one is the same as this one. They divide each other. Then you have the limit when x approaches negative 2, you have x squared minus 2x and then plus what? Plus 4. Then from here, you can distribute your limit. This is equal to the limit when x approaches negative 2 of x squared minus, since here we have the constant, we can just shift the constant 2 and then what? The limit when x approaches negative 2, we have x and then plus what? The limit when x approaches negative 2, we have 4. Then now we substitute our what? Our negative 2. Negative 2 all squared minus 2 and then minus what? 2. Then plus what? Plus 4. This is the same as what? This is the same as negative what? Is 4 and then plus what? Plus 4 plus 4. This is equal to what? Is equal to 12. Then this is your answer. So I believe now we can solve a problem if we are given a factorization method, a question that we can factorize. Then now let us move on to rationalization. All right, we are going to continue with our limit. We are going to look at the rationalization one. So how can you see this one is you have to use a rationalization method? You can see by the square root. If you have the square root, then you can say, okay, this one is a what? Is a rationalization method. So if we can substitute, if we can do the direct substitute, remember the first thing you must do a direct substitute. When I substitute my 0 here, I'm going to get 0, and substitute 0 here, I'm going to get the square root of 4, and the square root of 4 is 2 minus 2, and then all over 0. This is 0 over 0, and this is not allowed. So now we have to do something. Since we have a square root here, we need to do a rationalization. So how can we rationalize if we have something like this? Okay, this will be equal to the limit when x approaches 0, we have the square root of 4 plus x, and then minus what? 2 all over x. So we are going to take this one as it is and change just the sign. That means we are going to multiply by what? The square root of 4 plus x, and then plus what? Plus 2 all over the square root of what? 4 plus x plus 2. We just change the sign here. Then now you can see, okay, from here you can distribute. So as a result, we are going to have the limit when x approaches 0. This multiplied by this. You can see here we have minus and here we have positive. That means this one is a difference of 2 squares. We are going to just multiply this one and multiply that one. So we are going to have what? 4 plus x. This multiplied by this, the square root will cancel. And then 2 multiplied by negative 2, we are going to have negative 4. And then all over what? X, then the square root of what? Of 4 plus x plus 2. And then we close the bracket. Then this 4 and this 4 will cancel. So we have equal to the limit when x approaches 0. And then we have x all over x, the square root of what? Of 4 plus x, then plus 2. Then you can see now we have x and we have x. So this x will divide that x. Then now we have the limit when x approaches 0. We have 1 all over the square root of 4 plus x, and then plus what? Plus 2. Then from here you can distribute your what? Your limit. This is equal to the limit when x approaches 0, you have 1 all over the limit when x approaches 0, you have 4 plus the limit when x approaches 0, you have x, and then the square root, then plus the limit when x approaches 0, you have 2. Then now a limit when x approaches 0, then a constant, it will remain that constant. Then this will be equal to 1 all over, we have a constant, the square root of what? Of 4. And then here we substitute our 0 plus 0, then plus what? Plus 2. This is equal to what? 1 all over, the square root of 4 is 2, plus what? Plus 2. This is equal to 1 over 4. Then this is your answer. So we call this one a rationalization method. Then now we are going to pick the last one on the rationalization method part. We have the limit when x approaches 0, the square root of x plus 25, and then minus what? Minus 5 all over x. Then here you can see you have the square root, and then you have minus 4 here. So how are we going to find the limit for this one? Since we have the square root, we are going to use the rationalization method. Multiply the square root of what? Of x plus 25, and then plus what? Plus 5. Remember, we just changed the sign only. All over the square root of what? X plus 25, and then plus what? Plus 5. Then now you can see this one and this one is a what? Is a difference of 2 squares, since we have positive and what? And minus. So we are going to multiply this one and that one only. That means we have the limit when x approaches 0, x plus 25, and then this multiplied by that is minus what? 25 all over x, and then open bracket, the square root of x plus 25, and then plus 5. Then now you can see we have 25 minus 25 is equals to 0. Then this is equals to the limit when x approaches 0. We have x all over x, open bracket, the square root of x plus 25 plus 5. And then now you can see this x will cancel that x. Then this will be equal to the limit when x approaches 0, 1 all over the square root of x plus 25. Then plus what? Plus 5. Then from here, you can distribute your limit. This is equal to the limit when x approaches 0, you have 1 all over the limit when x approaches 0, you have x plus the limit when x approaches 0, you have 25, and then the square root. Then plus the limit when x approaches 0 or 5. Then now you substitute. Since here we have the constant, we are going to have 1 all over. We substitute our 0. This will be the square root of 0 plus 25. Then plus what? Plus 5. The square root of 25 is equals to what? 1 all over 5 plus 5. Then your answer will be equal to 1 over 10. Then this will be your answer. So I hope we are done with a rationalization part. Then now we can go to another one. All right, what about this one? How are we going to treat such a question? Say we have the square root of x and then minus 1. Then x minus 1. Do you think we can rationalize here? We cannot. Let us try to rationalize. This we are going to multiply by what? The square root of x and then plus 1 all over the square root of x plus 1. Okay, then now remember we have to multiply here. This will be equal to the limit when x approaches 1. Then this will give us x minus 1. Then all over what? X minus 1. Multiply by the square root of what? X plus 1. Then now you can see this one is the same as that one. Then now this will be equal to what? Will be equal to the limit when x approaches 1. And then we have 1 all over the square root of x plus 1. And then you distribute your limit. The limit when x approaches 1, you have 1 all over the limit when x approaches 1 and then x square root, then plus the limit when x approaches 1, you have 1. Then now this will be equal to 1 all over the square root of 1 plus 1. Then your answer will be equal to 1 all over 2. But there is another method that you can use. Remember, this one is a factorization, is a rationalization method. So you can also use a factorization method. Imagine if maybe you have the cube root here. You cannot just rationalize. We only rationalize if we have the square root here. I think we are fine there. So how are we going to treat a question if we have a cube root here? Okay, I will start by treating the one that we have the limit when, okay, let me just draw a line. The limit when x approaches 1, the square root of x minus 1 all over x minus 1. So I'm going to use a rationalization method. So in this case, you are going to let your a to be equal to, remember we we can write the square root of x as x to the power 1 over 2. Then I'm going to let my a to be x to the power 1 over 2, and then my b to be equal to 1. Then from here I can just write this the factorization of x squared, and then minus what? Minus b squared. This is equal to what? Is equal to a plus 1 plus b, and then a minus what? Minus b. Then now if we can solve a minus b, we can see where this one will move us back to this part. Then now we can divide by a plus b, and then here we divide by what? A plus b. Then now we have a minus what? B is equal to a squared minus b squared all over a plus b. Then from here, remember we said our a is equal to x to the 1 over 2, and then our b is equal to that one. Then now we are going to substitute everything. We have the limit when x approaches 1. Then now this one now is the same as what? Let us substitute here. X 1 over 2 minus what? Minus 1, because our a is equal to this, and then our b is equal to this. Then it's the same as this one. Then now we substitute. Our a is equal to what? Is equal to x 1 over 2 all squared minus what? 1 all squared all over x 1 over 2, then plus what? Plus 1. Okay, let me remove this one. Then this is the same as what? As x, because if we can multiply here, we have 1 over 2, and then multiply by 2, we are going to have what? X, and then minus what? Minus 1 all over x to the 1 over 2 plus 1. Then now we can see our x 1 over 2 minus 1 is the same as what? As this one. Then now we can replace the limit when x approaches 1 is equal to, where there is the square root of x minus 1, I'm going to substitute this. I have x minus 1 all over x to the power 1 over 2, and then plus 1 all over this one, which is x, and then minus 1. Then now we can see this one will cancel that part. Then now we have the limit when x approaches 1 is equal to what? 1 all over is equal to 1 all over x 1 all over 2, and then plus 1. Then now we distribute our limit. This is equal to the limit when x approaches 1 all over the limit when x approaches 1, we have x to the 1 over 2, and then plus the limit when x approaches 1. This is equal to 1 all over 1 to the 1 over 2, and then plus 1. So this is equal to 1 all over 1 to the power any number is equals to 1. Then this is 1 plus 1, which is equals to 2. Then we have 2. Then that is your answer. Yeah. Okay, see, now we have the cube root here. We cannot rationalize in this case, because if we are going to rationalize, we won't get the correct answer, or the square roots won't cancel. So we cannot rationalize. So in this case, we have to use the factorization method. So we can write this as the limit when x approaches what? 1, and then x 1 over 3 minus 1 all over x and then minus 1. Then now we can let our a be equal to what? X to the 1 over 3. And then we let our b be equal to 1. Then now we are going to use cube because here we have to the 3. Then that means we are going to take the factorization of a to the cube and then minus what? Minus b to the cube. This is equal to, we open bracket. Remember we said we are going to take our basis, which is a minus what? Minus b, and then we open bracket. Then now we are going to say a cubed divided by a is equal to what? A squared. Then now since here we have negative, here we are going to put positive. Then we say a multiplied by b is equal to what? Is equal to a b. Then here is always positive. Then we say a to the b to the cube divided by b is equal to b squared. Then now we are looking for what? For a minus b, because here we have minus. That means we are going to divide by what? A squared and then plus ab plus b squared all over what? A squared plus ab plus b squared. Then now we have our a minus b is equal to a to the cube minus b to the cube all over a squared and then plus ab plus b squared. Then now we can substitute our a and b. Remember our a is equal to what? X to the 1 over 3 minus what? 1 is equal to what? X to the 1 over 3, and then we put that 3 minus what? 1 to the 3 all over x 1 over 3 all squared, and then plus our a is equals to x 1 over 3, and then multiply by our b is equal to 1. Then now our b plus 1 all squared. Then now we can say what our x to the 1 over 3 minus 1 is equal to what? Is equal to x, because this 3 will cancel that 3, minus what? Minus 1 all over, here we are going to have x to the 2 over 3 and then plus what? Plus x to the 1 over 3 then plus 1. Then now you can see our x to the 1 over 3 minus 1 is equals to this. That means here we are going to substitute what? This expression. Then let us substitute. This is equal to the limit when x approaches 1. Then we substitute this. We have x minus 1 all over what? All over x 2 over 3 and then plus x 1 over 3 and then plus 1 all over what? All over this x minus 1. Then now this will divide that one. Then we have the limit when x approaches 1. We have 1 over x to the 2 over 3 plus x to the 1 over 3 plus 1. Then now we can distribute our what? Our limit. This is equal to the limit when x approaches 1. We have 1 all over the limit when x approaches what? 1. We have x 2 over 3 plus the limit x approaches 1. We have x 1 over 3 plus the limit when x approaches 1. We have 1. Then now we substitute. Since this one is a constant, we are going to get 1. And then all over we substitute our 1 to the 2 over 3 and then plus what? 1 to the 1 over 3 and then plus what? Plus 1. So we said 1 to the power any number is equals to 1. That means here we are going to have 1 over 1 plus 1 plus 1, which is equals to 1 over 3. Then this is our answer. Okay, so we are going to do the last one, which is a mix of the factorization method and the rationalization method. You can see here on our numerator we have x to the 3 and then minus 1. Then here we have the square root. That means here we have to factorize, and here we have to what? We have to rationalize. Then now this will be equal to the limit when x approaches 1. Then how are we going to factorize this? We open two brackets, then here we are going to have x minus 1. Then now we are going to say x to the 3 divided by x is x squared. Then since we have a negative here, we are going to write positive. Then we say x multiplied by 1 is equal to what? X. Then here is always what? Positive. 1 divided by 1 is equal to what? 1. Remember, we can write 1 as 1 to the 3. So now we have the same exponents. Then all over what? All over the square root of 2x plus 2 minus what? Minus 2. So here we have to rationalize. We are going to multiply by what? The square root of 2x plus 2 and then plus 2 all over what? The square root of 2x plus 2 then plus 2, since here we have what? Positive. Then now this will be equal to the limit when x approaches 1. Then we have x minus 1, x squared plus x plus 1. Then we have multiplied by the square root of 2x plus 2, then plus 2, all over what? Then now, since this one is a what? Is a difference of 2 squares, we are going to multiply this one and this one. Then now we are going to have what? 2x plus 2 with this multiplied by this. And 2 multiplied by 2 will be minus what? Minus 4. Then now we have what? The limit when x approaches 1. Then we have x minus 1, x squared plus x plus 1. Then we have the square root of 2x plus 2 plus 2 all over. Then now this and this will give us what? As a whole, this will give us negative 2. So we can say we have negative, we have 2x and what? And 2. We can take out the common factor of 2, which is 2, and then open bracket, we are going to have x minus 1. Then now you can see this is the same as this one. We are going to divide them. This will be equal to the limit when x approaches 1. We have x squared and then plus what? Plus x plus 1. And then multiply by the square root of 2x and then plus 2, then plus 2. All over what? All over 2. Then now you can do the distribution part, but now I'm going to substitute that one. So let us substitute. This is equal to what? 1 squared plus 1 plus 1. And then multiply by the square root of 2, 1 plus 2, and then plus 2 all over 2. Remember, you have to distribute your limit here, but now I'm substituting. So this is equal to what? 1 plus 1 plus 1 is equals to 3. And then we have the square root of 2 multiplied by 1 is equals to 2, and then plus 2 is equals to 4. Then the square root of 4 will be 2, then plus 2 all over 2. This will give us what? 3 multiplied by 4 and then all over 2. Then we can simply divide. This will be equal to 3 multiplied by 4 is equals to 12, divided by 2 is equal to 6. Then this will be your limit. Thank you.